Hello, students. Okay, so, um, I'm going to discuss today 2010 FRQ number 3, and that was the one that we were the weakest on, but it is one of the more important topics. We've gone over it a couple of times this year, and as I told you before, they like to have us interpret the F prime graph, and so this is a direct application of interpreting the F prime graph. Um, and this was assigned on Monday, and it was due on Tuesday, so if that helps you remember which problem this is. Okay, so what I have here is the question. There are 700 people in line for a popular amusement park ride. When the ride begins operation in the morning, once it begins operation, the ride accepts passengers until the park closes 8 hours later. So before I continue, we know that there are already 700 people waiting to be in line in the ride. Okay, then people start loading onto the ride. While there is a line, people move onto the ride at a rate of 800 people per hour. So that means that 800 people per hour is how many people are loading onto the actual ride and taking off, I guess. The graph above shows the rate R of t, and so it's important to know that we're talking about rate R of t at which the people arrive at the ride throughout the day. So these are basically people who are getting in line. So this graph represents the rate at which people are getting in line. Okay? Time t is measured in hours from the time the ride begins operation. So even though we have a graph of the rate at which people are going on, are going into the line, technically we have two rates. We have the one where people are getting in line, and we also have the one that people are getting on the ride. Okay? So how many people arrive at the ride between time 0 and 3? So that's going to be my next one. So when we are asking about how many people, the units are people. R of t is in people per hour, okay, which is this graph right here. So if we want people, what we need to do then is to find the area under the curve from 0 to 3. And so that's what I've done here. So I found the integral from 0 to 3, and you have R of t, which is people per hour, times dt, which is hours, is equal to, and what I did is I divided it up into two trapezoids. And you can divide it up in lots of other ways if you'd like. You could do a rectangle with a triangle here and another rectangle with a triangle up at the top. But I did two trapezoids. So it's 1/2 base 1, so 1,000 right here, plus base 2, which is 1,200 right here, times the height of the trapezoid, which is the distance between the two bases, plus trapezoid 2, which is 1/2 base 1 is this line right here, plus base 2, which is 800 at time 3. See, it ends at time 3. And times the height, which is 1, the distance between 2 and 3. And when you calculate all of that out, this is trapezoid 1, trapezoid 2, you get 3,200 people. And make sure that you put the units. And remember, how do we get people? Because we have people per hour times the hour. Okay? Then the next one. All right, so same problem. This time they're asking, is the number of people waiting in line to get on the ride increasing or decreasing between the hours 2 to 3? Justify your answer. Okay, so I think they put a very quick explanation, and I'm trying, the work that they have is all that's needed to, all that you need to show, which is very little. But what I have here is just a full explanation just so that you understand. Okay, so to determine if the number of people waiting in line is increasing or decreasing, you need to find the rate of the people waiting in line, if it's positive or negative. Okay, so waiting in line. So think about when you're waiting in line at an amusement park. Okay, you get in the line. Okay, but people are getting off the line because they're loading into the ride. So the rate at which the people are waiting in line incorporates people getting in line and the rate at which people are getting on the ride. So what I have is people waiting in line, and I label that W of T, capital W of T, is equal to people getting in line, the number of people getting in line, minus the number of people getting on the ride, and I label that Q of T. I don't know, I just came up with these variables. So I didn't have, you could say capital R of T, I guess you could say. But what is the rate of change of the people waiting in line? That would be lowercase w of t is equal to rate of people arriving at the ride, which is R of t, which is given to us in the form of a graph, okay? Minus Q of t, which is the rate of people getting on the ride. And that is also given to us, and that is flat. It's 800, which I also graphed right here. So when you do this, you want to find out when it's increasing and decreasing. So if you know that your rate is R of t minus 800, well, when is your rate going to be negative? Well, if your R of t is less than 800, because this equation will give us a negative if your R of t is less than that. And when is it going to be increasing? When your R of t is greater than 800, because this quantity will be positive. And so that's what I explained over here. Now, how can you use your graph to figure that out? Well, on the test, after you understand this a little bit further, on the test, all you do is you graph this 800 and you go, when is R of t greater than 800? Over here. And when is R of t less than 800? Down here. And they are the same when time is 3. So now they're asking specifically between 2 to 3. So 2 to 3. So if I look at the time interval 2 to 3, I can see my R of t, which is the rate of people getting on the ride, is greater than the rate of people that are, I'm sorry, my wording was wrong. R of t is the rate of people getting in line, and it's greater than the rate of people getting on the ride. So that means that between times 2 and 3, the rate of people waiting in line is increasing because R of t is greater than 800. So right here, if you can follow my mouse, right here is really all that is needed for you to write down in your work. You don't need all of this. I put that there just to help explain the problem a little bit further. Okay, hopefully that clarifies some things. All right, part C. I put that up here just so I can have room. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answers. Okay, so before I start thinking about this problem, I think, okay, the longest, what does that mean? That means I need a maximum, right? So then I start thinking about how do I find maximums or even minimums? Well, the first thing I need to do is I need to find a critical number. Then after that, I need to determine if my endpoints, which I could do here, or not necessarily, because I will explain further that you're not going to need to in this situation. But you could use the closed interval method and find your endpoints. So that since the first thing we have to do is find the critical numbers, well, what is the critical number? Critical number is when the derivative is equal to 0, okay? And we are trying to find the derivative of the people in line, okay? So using our work from part B, the people waiting in line is W of t, and then the rate of change of that is W prime of t, which is lowercase w of t equal to r of t minus 800. So what would the critical number be when r of t is equal to 800? So when does that happen? That happens when time is equal to 3. Opagak. This is when. Oops. Okay, well, when I copied this, I put the line too high because my 800 is at 1,000. So let me go back. The previous slide here shows my line at 800, and it's when time is equal to 3. So imagine that this line is shifted down, okay, at 800. And so that's when time is equal to 3. I just copy pasted but did not paste properly. Okay, so then you'll see that, well, when is waiting in line positive and negative? Well, when it's less than 3, it's positive, and when it's greater than 3, it is negative. Okay, and our time stops at 0 and 8. So now when you look at this, that means that we're going to have a relative maximum, which, since this is increasing and then decreasing and it's not doing any other turns, that means that you've got an absolute maximum. So since you can already determine you have an absolute maximum because that was the only critical number, then you don't have to do the closed interval method. Okay, which means you don't have to test your endpoints. Okay, so with that, let me go back to the question. It says, at what time is it the longest? Well, it's the longest when time is equal to 3. How many people are in line at that time? I calculate that here. And it says justify your answer. So here is my work. And right here is all you need to show, actually. Okay? All of this is not needed because you can state it right here. Okay? The line is the longest when time is equal to 3 because the number of people waiting in line is increasing when time is in between 0 to 3 and then decreasing when time is greater than 3 and less than or equal to 8. So this describes what you have here. And remember, you do not get points for a number line. You get points for interpreting your number line, which is what we have here. Okay, this is what you get points for. Okay, number line is just a good visual for you to understand what's going on. So now then, going back to how many people are in line. Okay, remember we talked about start plus total change. So this would be the start. Remember, there's 700 people at the beginning. That's what they said at, in the problem, 700 plus total change. So total change would be the integral of r of t minus 800, which I have it separated here. But if you do r of t minus 800, when you take the antiderivative of 800, it would be 800x, or actually in this situation, 800t, and 0 to 3 would be that right there. Okay? I think I do that in the next section, or the next problem. In any case, you're finding out the area of the people waiting in line or going on the ride minus the people getting on the ride. Okay, so this represents each of those rates, which you get 1,500 people. And don't forget your units. If you wrote this how I do in part D, you would be fine. Okay, you do not have to write it exactly how they have it in their scoring guidelines. Okay, but it does still need to be correct. So you'll see what I mean in the next one. Okay, so here's the next one. So what I was talking about is if you replace that x with t, you could have this integral 700 plus 0 to 3 and the integrand would be r of t minus 800 brackets dt. That's what you would have, okay? For part C, that's another option for your expression. Okay, part D. Write but do not solve an equation involving an integral expression of r whose solution gives the earliest time at which there is no longer a line for the ride. So that's a lot to think about. I mean, the solution's really easy, but it's a lot to think about. You need an equation, okay? So you need an equal sign, and you need something on both sides of your equal sign. You need an integral expression of r, okay? So you know you're going to have an integral r, whose solution gives the earliest time at which there is no longer a line for the ride. So basically, you have to solve for t, okay? So t is your variable, okay? So if there is no longer a line, that means that there are no people waiting in line, okay? So remember that people waiting in line will be people getting in line minus people on the ride. So now, but we do have to start off with the fact that we had 700 people to begin with. Plus, this is my total change of the people waiting in line. That's what I have here. This is getting in line minus getting on the ride. Okay? Now, we want to solve for this t. If you think back, here you are given a t, 3. Okay? So that then at this point you can find out how many people are in line. Okay? So now I want to solve for a t of when there are no people. So your variable has to go in your upper limit of integration right here, starting off at 0. And this variable right here, if you remember us doing these problems, has to be a different variable than that. So you can't have r of t. I believe they put s. So I just put x just because we're used to x's. Okay? So this is an application of your fundamental theorem of calculus, okay? And so this would be the equation. And I highlighted both of them because both of these could be an answer. You could have the first expression or you could have the second expression. And both of them would suffice and get you full credit. All right? Okay, I hope that helps you understand the problem. Thank you.